Hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW English. So, students, I welcome you all to your Nexus batch. And what are we going to cover today, ma'am? Today, we are going to proceed further to our chapter Chemical Bonding. So, till now, students, we have understood with regard to the Lewis dot representation, about valency, about formal charge. Yes. But now it's time to move further to very interesting part of chemical bonding. That is going to be overlapping. Yes, you heard it right, overlapping. So basically, what are we going to do? How are we going to proceed? Let us see one by one. So students, before proceeding, I would say if you have not seen the previous session, just go through the previous session once, because yes, revision is really very essential whenever you are preparing for any examination. See, what happens is, if you're preparing for something and if you're not revising it, you will retain that up to 2 or 3 days only. But after that, you're going to forget it. So it's better to revise each and every topic after each and every session. That's great. So ma'am, this is going to be which session? This is going to be our lecture number 3rd for our chapter, that is chemical bonding, under our Nexus batch. Yes? Okay. So now students, what are the topics we are going to cover today? So initially students, we shall be understanding about ionic bond. Though we have already understood about ionic bond in the first session of ours, where I told you that yes, the types of bond, yeah, in the modes of chemical bonding topic. So, but we are going to understand about the properties of ionic bond also. Yes, everybody. So, we shall be first of all looking up to ionic bond. Then students, after that, we shall be starting with covalent bond. Do you remember when I was explaining you about the modes of chemical bonding, I told you that by transferring of electrons or by sharing of electrons, you can see different bond formation. Yes, students. So by sharing of electrons, you used to see that coordinate bond is also formed. Covalent bond is formed. But by transferring of electrons, which kind of bond is seen? Ionic bond is seen. Which kind of bond is seen when there is a sharing of electron? Covalent bond. So we are going to see them in depth, and then we are going to start with the theories regarding covalent bond formation. So we are going to understand in depth about that, and we are going to start with the very first theory of ours, that is valence bond theory. Yes, students, we are going to start with valence bond theory. With valence bond theory. And at last, ma'am, what are we going to do? At last, we are going to do the most interesting segment of our today's session, that is overlapping. Yes, students, you heard it right. It is basically overlapping. So we are going to cover overlapping first part over here and second part in the next session though. So here I am writing overlapping part first. Clear everyone? Now starting with the very first topic of ours, let us meet your friends. Yes, barium and calcium. So calcium basically is saying, hello my shimmering stars. Have you revised yesterday's session? See, she is so much concerned for your revision part, right? Even I am. So students, do revise the previous session, because if you are not remembering the previous part, how can you move further in life? Yes? Okay. Now students, if I talk about barium, he's saying, hi friends, let us start with our this chapter, new topic. So yes, proceeding further, we are going to start with ionic bond. The name itself says ionic bond. That means there is going to be an interaction between cations and anions. Yes, everyone knows that. In the previous session, we heard about NaCl formation. Do you remember that? If not, no need to worry. We are going to revise all over here again. So, I am saying ionic here word refers to where we are going to understand about cations and about anions. That means we are going to focus upon ions in short. Yes, cations are the one which have a positive charge, and anions are the one which have a negative charge, and when positive and negative are going to interact with each other, that will lead to the formation of ionic bond. Now, how does ionic bond takes place? By transferring of electron. Yes, let us take one example that we have already done, but yes, for your revision sake. That is formation of Formation of NaCl. Yes, ma'am. Formation of NaCl. Now, how does it take place, ma'am? First of all, there will be an cation formation. What will happen? The very first initial step will be formation of cation. Formation of cation. Yes, now how cation will be formed? See, here we have sodium, Na. Na has an atomic number 11. Yes. So now, when we are going to write the electronic configuration, it is going to be 1s2, 2s2, 2p6, 3s1. Yes, ma'am. Very simple thing. So, if I ask you over here, which is the stable configuration for the case of Na? How Na is going to attain a stable configuration, ma'am? By losing one electron. Yes. So, by losing this one electron, it can attain a stable configuration, no? So, what will happen? It will lose one electron and will acquire a state of Na positive. That means if the 3s1 electron, if the outermost shell electron gets, it will liberate this outermost shell electron, then it will attain a stable configuration which has the completely filled orbitals. How I am saying that? If you are not getting my point, you can even write it in such a way. 1s2, 2s2, 2p6, 1, 2, 3, 4, 5 and 6. Yes. And then comes 3s1. Yes. So over here you can clearly observe that what happens? That ma'am, this orbital, either it requires one electron in order to attain 3s2, either it can lose one electron and complete its octet. Yes. So octet will be completed when there will be 8 electrons in the outermost shell. But over here, outermost shell contains only one electron. It is not at all stable. It is half filled orbital. So what it is going to do? It is going to lose one electron. Then it will attain till 2p6. That means configuration fully filled. Now, this electron which it has been liberated over here will be used by the formation of anion. Will be used in the process of formation of anion. Now, what will happen over here? The second step. The B part is formation of anion. Formation of anion. Now see students, what is going to happen over here? Here you know we have Cl with us. Cl has an atomic number what? 17. Yes, Cl has an atomic number what, ma'am? 17. Now when you are going to write the configuration of Cl, what you are going to observe? It has 7 electrons in the outermost shell. If you want to write, you can even write it over here. 1s2, 2s2, 2p6, 3s2. And then it comes out to be what? 3p5. See, outermost shell contains how many electrons? 2 plus 5 is 7. See, count total electron. 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. 12 plus 5 is 17. Yes. So, it contains 7 electrons. That means it requires how many more electrons? It is 3s2. 1, 2, 3, 4 and 5. 3p5. It requires only one electron. So, the electron being lost by Na will be acquired by chlorine. So, when this is going to acquire that electron, it will form what? It will form Cl negative. What it will form? Cl negative. Now, many of the students also have doubt in this concept. Why Na positive is formed? Why not Na negative? Why Cl negative is formed? Why not Cl positive? Always remember this, students. For example, if I am Na, I am neutral species, okay, and I am losing one negative charge. Understand, I am neutral, equal positive, equal negative. If negative is going, I will be positive. Okay, so it became positive. Now in this case, I am a neutral molecule, equal positive, equal negative. Yes, so now negative is being added. If you're adding a negative charge, you will get a negative charge. So it got a negative charge. That means this Na positive and this Cl negative that we obtained as a product will combine with each other and will form NaCl. So there is an attraction between cation and anion, the electrostatic force of attraction between both the particles. Always remember, positive will repel, negative will attract. Negative will attract. No. Positive will repel. Negative will repel. But positive and negative will attract. Like charges will repel each other. Unlike will attract each other. Got my point? So if you're bringing two positive together, they will move apart. If you're bringing two negative together, they will move apart. But positive and negative, they will come together. This is what is happening. Na positive, Cl negative coming together. NaCl is being formed. Now students, see over here. An ionic bond is formed by complete transference of one or more electrons from the valence shell. Now what is valence shell? If you don't know, if you still have a problem in that, it is outermost shell. Yeah, it is outermost shell of an electron to valence shell of another atom. Yes. So this electron from 3s1 is moving on to the 3p5. 3p orbital of the Cl negative one, right? Force of attraction is equal in all directions, so ionic bond is non-directional in nature. This is one of the characteristics. Let us focus on some more characteristics. I guess this everybody has written. If not, students, be fast. Write it down, students. Now, let us understand about the characteristics of ionic bond. First of all, they are hard, they are brittle, they are crystalline. So what is crystalline? I guess you somewhat know about solid state chapter. So you know what is crystalline amorphous. The which has a regular arrangement of particles is basically crystalline structure. So they are hard in nature, they are brittle in nature, they are crystalline in nature, they have high melting and boiling point. Moreover, they are polar in nature. What do you refer to term polar? Polar refers to as creating poles. For example, a positive and negative pole being created over there. Yeah. So that is they are polar in nature. Then the linkage between oppositely charged ion is non-rigid and is non-direction. Okay, the linkage between two opposite ion, positive and the negative one, is non-rigid and is non-directional. Next, they are soluble in polar solvents only. For example, if you are talking about NaCl structure, it will be soluble in water only. Water contains what? Water also contains the polar ones. For example, which generate poles, positive and the negative one. Oxygen will gather -2 charge. Hydrogen will gather +1 charge. Yeah. So NaCl, in the case of NaCl, you can clearly see that yes, it is being soluble because they can be soluble in polar ones. And they're insoluble in the non-polar ones such as CCl4, benzene 1, ether 1. So they're non-soluble in all of these cases. Clear? Now, some more characteristics. They are good conductor of electricity in fused state. And in solution, it is, but due to its mobility of ions. Because what is mobility? The movement of the charges, right? The next part, they are bad conductor of electricity in solid state. Because in solid state, particles are so tightly attached to each other, they cannot move. So in fused state and in the solution, only they can show the movement, so they can be a good conductor. But in the case of solid state, they are bad conductor. Always remember this. Clear? That's great. Now students, moving on to covalent bonding. We very well know, ma'am, covalent bonding is seen by sharing of electrons. Covalent bonding is observed by sharing of electrons. Yes. Now it is also being observed when there is a difference in electronegativity. What is En? En basically is electronegativity. So when there is a difference in electronegativity, then the covalent bond formation can take place. Also, what is electronegativity? It is basically tendency to attract shared pair of electrons. Now, many of you will say, ma'am, you have explained this topic in your third chapter also, that is the classification of elements, and also here again. But let me tell you, if the topic is being repeated and I feel like yes, it is important, I will be saying it again and again so that it is here in your mind. Yeah, because revision, speaking topics, understanding topics again and again will make you more stronger in that topic, in that part. Now, I guess you very well know about covalent bonding. Let us start with the very most important part, that is types of covalent bonding. Sorry, theories of covalent bonding. See, in case of theories of covalent bonding or theories with regard to covalent bonding, which are these, the very first we have already done, that is Corson-Lewis electronic theory, in which we have studied in depth about Lewis dot structure. Also students, we have understood about what? Also we have understood about octet rule, or we can also say Lewis octet rule. We can also say Lewis octet rule. Yes, everybody. So Coastal-Lewis electronic theory is based upon the Lewis octet rule. That means each, element has to complete it octet or duplet. What they have to do? Each and every element has to complete or has to attain either octet or duplet electronic configuration or duplet electronic configuration. Clear? Now students, coming to the next theory that we are going to start today is going to be VBT. What is VBT, ma'am? It is valence bond theory. What it is? Valence bond theory. Now valence bond theory in depth will make you understand about the concept of overlapping. About the concept of overlapping in detail. After that, we are going to start with the VSEPR theory, and the last will be MOT, the molecular orbital theory. Let me tell you, it is the most important one. And in this also, writing electronic configurations is yet again the most important one. Clear, students? So starting with the very first topic we have already done, second topic, that is valence bond theory. What is according to valence bond theory? See, valence bond theory gave you the concept of overlapping. Yes, it gave us the concept of overlapping. That means in other terms, it explained us the concept of sigma bond and pi bond formation. Sigma bond and pi bond formation. How does sigma bond and pi bond formation occurs? It explains us about various properties. Yes, how it occurs, how it takes place. Let us understand in depth, students. Let us understand in depth. Now see students, as per valence bond, before starting valence bond theory, we should have a detailed information with regard to orbitals. I am coming to valence bond theory, no need to worry out. It is a concept of overlapping though, but yes, first of all, let us understand some things about orbitals. Okay, so basically students, this topic I guess you have already done in your second chapter, that is atomic structure. If not, we are going to revise it. See, when I'm talking about orbitals, we have s orbital, p orbital, d orbital, and f orbital. Let us take all of their cases one by one. Okay? And yes, we are going to understand about two major terms over here. That is going to be G-rayed. What is a G-rayed orbital? What is un-G-rayed orbital? The next thing what we are going to understand is what is T2G orbital, what is EG orbital. We are going to understand this new concept also over here. Now coming back over here about SP, D and F, let us talk about S orbital, students. If I'll talk about students, the S orbital. Yes, what I'm talking about over here, the S orbital. Do remember, S orbital are basically spherical in shape. They are basically spherical in shape. For example, this is our s orbital. This is spherical in shape, right? And yes, either it is positive written over here, or either it is negative written over here. What it is in actual, it represents a wave function. Yeah, so now it is basically spherical in shape. Now question is why it is spherical in shape? Because the electron density, probability of finding an electron density is present in all the directions. So it creates a sphere. Why it is spherical? Because probability of finding an electron, is seen in all directions. So basically this comes out to be what? Spherical in nature. Now how many s orbital are there, ma'am? Only one s orbital are there, and one s orbital contains maximum of 2 electrons. Yes, everybody. Let us talk about whether it is G-rayed or not. What is a G-rayed orbital? For example, if you're taking this a particular axis and here is the s orbital, right? If you're rotating it at a particular angle, let us say if you're rotating it like this, okay? 180 degree. So what are you going to observe? If it is positive over here, you're going to rotate it. You will still get positive. That means this is a G-rayed orbital. So Girard orbitals are the one if you are spinning a particular orbital at a certain axis and you get the same spin. You know, the positive positive or the negative positive, that if you're getting the same spin, it is Girard. If you're getting the different spin, it is un-Girard orbital. Clear everybody? Clear everyone? Yes. So this is an example of s orbital which is spherical in nature. First of all, everybody write down so that I can now move on to the p orbitals and I can show you the 3D imaginations also. So students, now you can clearly see in this particular image that I'm showing you over here with regard to s orbital. This is s orbital which is present in all the directions, right? So when you're going to rotate it, you can clearly see that these are certain axes. One is x-axis, another one is y, and the third one is z. So when you are seeing that it is present in all the directions over here, right? So this is s orbital which is spherical in shape and is present in all the dimensions. Moving on to the next part. Now we are going to start with the p orbital over here. Everybody just have a look at the p orbitals. Now, there are, let me tell you first and then I'll show you this over here. So, p orbitals basically are of three types. That is basically your px, py and pz. And let me tell you, they are dumbbell in shape. What are these? These are basically like this, dumbbell in shape. One will have a positive sign, another one have a negative sign. Again, repeating the same thing. This is due to the wave function. Now, what is px, what is py, what is pz? This is basically that on which axis does the lobes lie, okay? So if I'm talking about px, if it is x-axis, lobes will lie on the x-axis. This is positive, this is negative. Now, what is py? This is your y-axis. So lobes, when they are going to lie on the y-axis, it is going to be py, positive and negative. If I'll talk about the pz one, this is the z-axis. When lobes are lying on the z-axis, it is going to be pz, right? Now, why they are dumbbell shape? Again, a question arises. They are dumbbell shape due to the presence of electrons. See, where there are electrons, the shape it will acquire. Yes, everybody, clear with this part? I'm showing you, and then we are going to see whether they are Girard or not. Yes? Okay. Now, see the structure. Students, you can see this is p orbital. Yes. Px, py, pz. Yes. Repeating again. See, this is px, the red one, right? Now, it will be py, the orange one, and the yellow one is pz orbitals. Clear? These are dumbbell shape. Now, question comes, what is a nodal plane? What is a nodal plane, ma'am? What is nodal plane? What is nodal plane? So, nodal plane, it is the area where probability of finding an electron is 0. What is a nodal plane? Nodal plane is an area where probability of finding an electron is 0. So if I'm asking you over here, let us consider there is a lobe which is present at px. Okay, let us take an example. For example, right, this is your y-axis, this is your z-axis, this is your x-axis. Let us say we are drawing px. So it is somewhat like this. I'm shading it. What is the nodal plane where electrons are not seen? Now, electrons are seen at the shape which is being acquired. That means they are present at the lobes. Now, you know, YZ is the plane where no electron is seen. If electron would have been seen over there, it would have acquired some shape. That means the lobe over here, you know, p orbital is dumbbell shape. Dumbbell shape comes due to the probability of finding an electron over there is possible. That's why it creates a dumbbell shape, because it is present at that area. Now, what is the nodal plane where probability of finding electron is 0? So over here it is YZ plane. This plane. This plane. For example, this plane is YZ plane. This is one lobe and this is another one. This is PX. And this over here, there is no electron. Clear, everybody? Clear, everybody? Now let us talk about the Girard and the un-Girard part. Whether it is Girard or not. Whether it is Girard or un-Girard. So let us rotate it. For example, let us take a case of, first let us take a case of PX. First, let us take a case of Px. So if it is px like this is your x-axis. Here it is positive, negative. You are rotating at 180 degree. What you will get? Negative will come over here, positive will go over here. That means it is ungyred because the signs get changed over here. So this comes out to be ungyred orbital. Clear everybody? Now you very well know about p orbital. Shall we move on to the d orbital, guys? Very good. How many p orbital? One more thing. How many p orbital are there, students? 3p orbitals already discussed, px, py, pz. How many electrons can be filled? 1, 2, 3, 4, 5 and 6. That means 6 maximum electrons can be filled in the complete p orbitals. Now students, come your d orbitals. Now here it comes your d orbitals. How many d orbitals are seen, students? See, basically it is 5. Which? dxy, dyz, dzx, dz square, dx square, y square. So let me tell you, initial 3 are non-axial. Initial 3 are non-axial and the rest of the 2 are axial. Now, what are axial and non-axial? Axial are the one in which the lobes are present on the axis. Non-axial are the ones in which the lobes are present in between the axis. So, even if you want to write, you can write non-axial is the one in which lobes are present in between the axis. Right? And axial ones are those in which lobes are present on the axis. First I will draw and then I will show you it over here. Let us now discuss about, okay, let us now over here discuss about dxy first. So consider this as your x orbital, as your y orbital. So lobes will be present in between the axis and it is basically double dumbbell in shape. It is basically double dumbbell in shape, right? So this is what is dxy. Well, lobes are present in between the axis, right? How in actual it is going to be seen? If it is positive, it is positive. It is negative, it is negative. In such a way. Clear, everybody? Now, the next one is dyz. Let us consider this is your again y-axis, but now this is z-axis. See, if you don't know how to represent z-axis, but you can also mention. If you're mentioning, the examiner will consider it as that particular axis. So, this is z-axis. Now, the lobes will lie in between the axis. This is dyz. No need to worry. This is 2D structure which I am drawing. That means on the 2D plane. Now I will show you this video also, you will get to know in the 3D one. Now comes dxz or dzx. See. That means if it is x-axis, this is z-axis. Basically, this is dxz. We generally say it as dxz only. So it is again the same way. But you have to mention the axis. Now, in all of these cases, what are these? In all of these cases, ma'am, we observed it is non-axial because it does not lie on the axis. It does not lie on the axis, right? Let us now draw over here the dz square and dx square y square. So, let us see about dx square y square first of all. See, now it is axial. That means it is x-axis, y-axis. Lobes will be present on the axis. Lobes will be present on the axis. On the axis. So this is dx square y square. Clear, everybody? In actual, if you want to see, positive, positive, negative, negative. In such a way it is, right? But yes, you have to mention this is your x-axis you're considering this as y-axis. Now the next one is dz square. It is quite different from all of these. Here, if it is your z-axis, one lobe is going to be like this and another there will be a ring-like structure over here. Another there will be a ring-like structure over here. So this is dz square. Now coming to these two over here, students, these both are axial because lobes are present on the axis. Now one more thing. If I ask you the nodal plane over here, what will be the nodal plane? See, it is present See now, x, y, they are present in between the x's. So you have to tell me the answer in the comment section. What is the nodal plane? Yes, but there is one confusion that everybody have seen is in the case of dz square. I will tell you for dz square, but the rest of them are very simple. So you have to write in the chat section. If you won't get it, then write in the chat section, ma'am. Please tell. I will tell also. Okay. Now see, in dz square, what is the nodal plane? Here, you know, a cone-like structure is being obtained as a nodal plane where probability of finding an electron is 0. So now as such nodal plane, but yes, a cone-like structure is obtained wherein there is no electron seen. Yeah? Clear everybody? Now let me show you the structures. See, this is dxz. That means in between dx, in x-axis and z-axis. Right? In between these x's. Now this is dxy. See, this is x-axis, y-axis. So in between the x's, this is dxy. Next it will come out to be which one? This is the next one, xz. So they are representing all of them together. This is dx square y square on the axis. Dx square y square on the axis. This is dz square. Now you can see the structure of dz square over here, students. Everybody, are you able to see this? Very good. Very good. Now moving on to the next part. We are going to start with the f orbitals. So there are 7 f orbitals. No need to go for f orbitals in detail because that is not in your syllabus. But yes, I will show you. These are f orbitals. These are 7 f orbitals. So you should at least see how they actually look like. Yes, these are the f orbitals. Clear everyone? Now students, we are going to proceed with our next part. We have already covered the orbital shape over here. Yes, we have covered orbital shape over here. Now we are starting with the overlapping topic. With which topic, ma'am? Overlapping. With overlapping segment. See, let us understand overlapping now in detail. Overlapping is basically intermixing of orbitals. Yes, what is overlapping? It is basically intermixing of atomic orbitals in order to form sigma bond or I bond. Let me tell you, overlapping students is of two types, axial overlapping and sideways overlapping. Axial overlapping and sideways overlapping. Axial overlapping and sideways overlapping. Sideways overlapping is also referred to as lateral overlapping. Lateral overlapping, or it is also referred to as parallel overlapping. These are the terms that you can give to them. Yes, now we are starting with the very first one, that is axial overlapping. We are starting with the very first one, that is axial overlapping. Understand, axial overlapping will lead to the formation of sigma bond. Sigma bond is a single bond, the initial bond being formed. Let us take certain cases. If I am taking a case of s plus s orbitals, how overlapping will take place? See, s orbital is spherical in shape. Yes, students, just please give me a minute. So students, I guess now you all have written the overlapping part. As I was drawing the structure over here, there was a board problem. So now I'm going to continue from this part only. See, I was talking about axial overlapping, right everybody? Now in the case of axial overlapping, I told you that over here sigma bond formation takes place. Sigma bond is the initial bond that is going to see over here, right? Now I am doing overlapping of s and s orbital, which I was doing, but yes, due to some issue we didn't continue it over here. So yes, now this is s orbital and this is s orbital. I am making it again, okay? I'm making it all over here again. So no need to worry about it. Now see students, here when they have not mentioned you, when they have not mentioned you any kind of x's, always remember you are going to take internuclear x's as your z-axis. Now, what is internuclear axis, my dear students? Whensoever you are showing your orbitals, you are representing your orbitals, there should be a particular axis. When it is mentioned that yes, draw an x-axis, draw an y-axis, on z-axis and so on, you can go accordingly. But if it is not mentioned, take z-axis as your internuclear axis. Now, when s and s orbital combine, what are they going to form? See, they are going to form what? This is the formation of, ma'am, sigma bond, and what it is also referred to as overlapping region. What it is referred to as, ma'am? Overlapping region. Clear, everybody? So this is basically, the overlapping of s and s orbital that takes place over here. Now you very well know s orbital is spherical in shape, and over here all the electrons are present in such a way that it creates a sphere, right? But when I talk about the overlapping of S and P, what will happen? Let us discuss about overlapping of S and P orbital. Let us discuss in detail. If I talk about S orbital, ma'am, we very well know it is spherical. So here I am taking internuclear axis as z-axis, and I am taking a case of Pz and S, right? So this is going to be my S, plus I am going to take Pz. So if I am considering this as your z-axis, this orbital will be my Pz. Now only you have seen what is Px, Py, Pz, we have seen in the previous slide, right? So when we are going to do the overlapping, see, this is our S and this is our P orbital. Yes, everyone? Yes, so over this region is the overlapping region, and this is sigma bond. Now in actual, how does it occur? It is going to occur like this. This is S orbital, this is P orbital. This is the overlapping. Clear, everybody? Clear, simple key concept over here about axial overlapping. Okay, let us talk about now sideways overlapping. About what, ma'am? About sideways overlapping. About sideways overlapping. So if I'm talking about sideways overlapping, now we are going to take different cases. Here I'm going to take, Py and Py. And I'm saying take your axis as x-axis. So how you're going to do? If it is your x-axis, you are going to draw Py and Py. This is your y-axis, this is your y-axis. This is your Py, this is your Py. Yes, everybody? This is your y-axis, this is your y-axis. You are going to intermix them all together. What are you going to form over here, students? See, just observe. This is what is the formation of orbitals that takes place. This is a formation of a bond that occurs. Now, this kind of bond that is formed over here is pi bond. And in actual, students, how electrons are distributed, how the overlapping occurs. See, in axial overlapping, the overlapping was like this. In sideways overlapping, it is like this. The one from the upper end and the one from the lower end. So, in actual, if I have to show you electrons over here, how will I show them? Ma'am, in actual, they are going to look like this. In actual, they are going to look like this. This is what is this is what is sideways overlapping, the formation of pi bond over here. Clear, everybody? Very simple thing, very basic thing we are going through. Now, you are going to see different kind of bond formation if you are taking different kind of axes. Let us discuss them one by one. Everybody, first of all, write down. Then I am going to give you some axes, and then I am going to draw all of these structures one by one. Everybody, please note it down. Be fast, students. Okay. Starting with the very first part, we are going to take S orbital, Px orbital, and we are going to take on x-axis. Let us draw this. See, if it is your x-axis, you have to take S orbital, you have to take Px. This is Px, this is S orbital. Now, how overlapping will take place? Yes, this is overlapping. How it is going to occur? This is again your x-axis. So, this is the overlapping region. That means this is the formation of which kind of bond, ma'am? Sigma bond. This is the formation of which kind of bond, ma'am? Sigma bond. Yes, everybody? This is the first case. This is the first case. Let us take another case where you have s orbital, you have, px or py, but here you are taking z-axis. Here you are taking which kind of axis? The z-axis. Yes, everyone. So now see, this is your s orbital, this is your z-axis, internuclear. Now you are going to draw px or py. Let us consider initially we are drawing py. This is ma'am py. How overlapping will take place? In this case, see students, if you are making them overlap, what you are going to observe? Is this possible? It is coming close. No. So that means this is zero overlapping. This is zero overlapping that occurs over here. This is zero overlapping that occurs over here. In the next class, you will get to know positive, positive overlapping, negative, negative overlapping, positive, negative overlapping, and the zero overlapping. You will get to know that if positive, positive are combining, it will form bonding and molecular orbital or anti-bonding molecular orbital. Yes. So everybody just write down the second one over here. It is zero overlapping. Clear? Now let us take another case, the third case. Third case is of when you are taking px and another px on x-axis. Px and px on x-axis. Now see, this is your x-axis, right? Initially you are taking px, this is your another px. Px and px, and you are doing what, ma'am? We are doing overlapping. So how will it look like? It will look like this, students. This is again your x-axis and this is your overlapping region. Again, this is sigma bond. Why? Because it is taking place on a single axis, on a single plane, right? Over here, if you'll see in the pi bond, the plane is different. It is coming like this in a 2D way. But over here, it comes like this on a single axis. So that's why again it is a formation of which kind of bond, ma'am? Sigma bond formation occur. And the shaded region over here is the overlapping region. Yes, everybody. That's great, everybody. Please write it down, students. Now moving on to the next part. Let us take fourth part over here. That is px plus px overlapping on y and z axis, either on y or on z. See, let us consider this is your x-axis, okay, sorry, this is your y-axis. I am just taking an example, and this is your x-axis. So this is px, this is another px, right? Now this is up to me what axis I am taking. If you are not mentioning any axis, that means it is z-axis. So now see, now let us see the overlapping region. This is first orbital overlapping region, this is the second one. Again, you can see these are the overlapping regions and it shows the formation of pi bond over here because they are showing formation in such a way like this. From the upper part, from the lower part. This is the formation of which kind of a bond, ma'am? Pi bond. This is the fourth case. Shall we take the next case? Everybody write it down first. Everybody please do so. Now we are going to take a case where we have px, py on the z-axis. Px, py on the z-axis. Now see, this is your z-axis, this is your y-axis, let us consider this is your x-axis. This is your y-axis, let us consider this is your x-axis. Let us draw px first of all. Ma'am, px is going to be like this. Now let us draw py. Py is going to be like this. Now which kind of bond formation is taking place over here, students? Which kind of bond formation? Again, it is a case of zero overlapping. Again, it is a case of zero overlapping, my dear students. Is it clear to each and every one of you? Everybody please write it down so that we can move on to the next part of ours. Everybody please write it down so that we can now move on to the next part of ours. Clear, students? Clear, students? That's great, students. Now moving on to the next segment. See, this was overlapping of s orbital, p orbital. Now when I'm talking about the, overlapping of d orbital, we are going to see the formation of which kind of a bond? The coordinate bond. Which kind of a bond, ma'am? The coordinate bond. So how that formation occurs? For that, I am giving you one homework for today's class. One homework for today's class is to draw overlapping for d orbitals, like take a case of d orbitals and then just start doing the overlapping. First of all, identify, students, that which orbital basically is going to do overlapping. First identify that and then finally go for further cases, right? Now I guess everybody knows how overlapping is going to take place, how overlapping occurs, how axial overlapping, how sideways overlapping takes place. Axial overlapping will always take you towards the formation of a sigma bond. Sideways overlapping will always take you to the formation of pi bond. Do remember these basic things. Clear, everyone? So I guess all of these structures is clear. Now this is, if you want to represent, this is basically your electron cloud, how in actual it looks like. How in actual it looks like. This is the representation for electron cloud. Clear, everybody? Clear. So these are certain cases that we have written for overlapping. So these are cases of overlapping, everybody, for S and P. That is, this is overlapping part 1. Part 2 will be done in the next class of yours. Clear, everyone? Everybody, I guess you have drawn these structures. Now, before ending, let me give you an idea about bonding molecular orbital and anti-bonding molecular orbital. Bonding molecular orbital is the one in which we are going to say that sigma bond formation is being seen, first of all. Second part, if you are going to see as per the molecular orbital theory, you are going to fill electrons first in the bonding molecular orbital and then in the anti-bonding ones. So one by one you will get to know about that concept, and over here also in overlapping, positive and positive. I have told you in the class itself there is a positive symbol, negative symbol, right? So when positive and positive overlap, what are they going to form? Are they going to form bonding or they are going to form anti-bonding? So this also we are going to understand in depth in the overlapping part 2 in the next session. Yes, everybody. So yes, thank you so much, my dear students. Now we shall be meeting in the next class. Till then, keep smiling, keep learning. Thank you so much and have a good day, my dear students. Bye bye. Take care.